Okay, hey, think we're going. Hey, happy whatever day it is. I am having a good day. No wasp stings today, and the Benadryl is finally worn off, so I'm ready to go. All right, doing more coding challenges in Kotlin. And so let's do this thing. All right, so today's challenge in LeetCode is first unique character in a string. Also, happy Cinco de Mayo. I'm drinking some wannabe sangria. First unique character in a string. Right off the bat, it sounds like a problem that we did last month. And I should mention that's like one of the best things about practicing problems like this is that a lot of them are similar. So hopefully, what's up, Fraz Tubes? Cheers. Is one of the nice things is that sometimes you recognize problems or see problems that are similar. This can also backfire, as we've seen on prior streams, where I'm like, oh, this reminds me of another problem. Let me try and solve it that way without thinking about it, and then I end up missing some nuances that make them different. Hopefully that's not the case here. We're trying to find the first unique character in a string, so we're going to loop through, and we'll return the index. So the problem that we did before was finding the first unique number, or rather it was the only unique number. So in that situation, what we did was we went through and we did an XOR of all the numbers, and we ended up with the only unique number. That XOR only worked, one, because there was only one number, not multiple unique numbers that were unique. And two, we returned the number. In this case, we're returning the index. So the problem that I was just referring to actually doesn't help us at all in this case. So that's a bummer. And we're doing this in Kotlin. For all I know, they probably have like an ordered set. I don't know that would necessarily help us. So what I'm kind of thinking about doing is basically looping through all the items. We have to do that no matter what. And basically keeping track of ones that we've seen before. So what I'm kind of thinking about is basically keeping a hash table with a count. You know, I'd like to do a set, and I thought maybe we could kind of loop through and say, hey, add the L, O, V, E. Oh, we got another L. Delete it from the set. It's no longer eligible. But the problem is I have to know that we've seen an item before. No hashes or dictionaries. Oh, boy. Okay. All right, let's figure this out then. So without a hash table or a dictionary, what else is there? Well, we could do the XOR trick. Is that true? No, that won't tell us the first one. I can only think of bad ways. Hey, what's up, Vlados? To solve it without hashes or dictionaries. But I'm okay with doing things in a bad way. Feeling kind of bad today. Feeling like a bad boy. So if we didn't use a hash, we didn't use a dictionary. I don't think tree helps us. Okay, it's all lowercase. What is... Okay. Okay, alright. So how about an array with 26 indexes? Since Vladis called out they're all lowercase. Or actually, sorry, RazTubes, you mentioned all lowercase. So yeah, you gave me the hint. So we could do an array here and basically just mark it if we've seen it, basically. So I don't know how you can do an array in Kotlin, actually. So let's take it to the IDE. There's something sad about IDEs, like, they really do make it easy for you to be able to code in a language for months and not know how to create an array. Yep, just keep track of the index. I like it. And this problem's called unique character. Oh man, Vlados, this keeps happening. I don't know why, but the way I fix this every day is by going in the chat box, click at properties. And can only do this after we go live. Go to source and refresh cache. And when I click done, it should work now. Isn't that ridiculous? So fix, thank you. Let's close all these things. And, oh, what did I just do? I thought I created a new class, but I guess not. Unique character test, and this should have also been a test. Yeah, I appreciate it. Need some distraction. These troubled times. Let's see. I don't know if y'all have seen the TV commercials that play the sad music saying, "These challenging times, we just want to let you know that McDonald's is here for you and we love you. We're all in this together." I am, quite frankly, very tired of these. Oh, man. Roll. Good call. Gosh. We could do a 26-bit. Oh, yeah. I see what you mean. Yeah, good call. An array of 26 would not tell us. So, I mean, we could store the index that we've seen. Yeah. I wonder if we could do a heap. What about a queue? Yeah, so 2 arrays is good. What if we did a heap based on frequency? Yeah, let's do a heap. I haven't done a heap in like a week. And it's, is it any better than an array? No, surely not. They are lifting all measures about tripling time starting in tomorrow. Oh, nice. Congratulations. It's still kind of restricted here. I wonder if Kotlin has a built-in heap. Kotlin built-in. Let me do it in the other browser. Do they have a, we'll call it a min heap? Yeah. Yeah, heap is pretty silly. Oh, it's not silly. They have their uses, but not very often. What's this? Binary heap. Okay, yeah. I want to know if it's built in. Heap is a heap data structure written in Kotlin. Oh, you know, if I use third parties, though, I'm not going to be able to bring it in. Dang it. To LeetCode to prove it. All right, let's just do arrays. I don't want to write a heap again. I don't know. Okay, tell you what. Let's vote. Who wants to see a heap and who wants to see an array? A multi-dimensional array. First person to respond wins. And I'll just be here celebrating until someone picks. This is not very good wine. I don't really like wine anyway. All right, YOLO. YOLO it is. Oh, wait. Oh, sorry, Vladis. You were not first. Looking at those. I see heap. There we go. RazTubes beat you to the punch. So, let's do this. What is all this stuff here? All right, let's just get rid of all that. And we'll bring this in. There's our class. It's got the squiggles for some reason. A redeclaration. Oh, that's because I forgot to do a class of unique character test. All right. So this time, learning from Vlados, we're going to separate the data structure from our solution and just call it frequency heap. All right. And does it need to take anything in to begin with? Nope, I don't think so. Frequency heap has, what does it have? Has methods like add. What else? Do we only need to add? And add, whenever we add an item, we'll basically see if it already exists in the heap. Oh, heaps aren't good for searching. Good to do. How do we know if our item is in the heap already? We could use a multi-dimensional array. That's true. Heck yeah, man. I couldn't find a heap built into Kotlin in the 30 seconds I Googled for it. So yeah, why not try to do a... oh, is there a native heap built in? That would be no fun. Okay, no, that's really like heap memory. So yeah, let's just do a heap. So I'll add an item if it's oh man, I keep thinking of reasons why this won't work. Oh yeah, definitely writing your own heap is not a good idea. I'm sure there are like way better ones, but the problem with the heap is I don't know which one has been added first. So really, I need terrible use of a heap. We need to know the frequency, but we also need to know which one came first. Is there another way? Hey, if we're doing terrible things, we could just like jam the numbers together, since all we ever care about is like one or many. So we could do something that relies on alphabetical sorting. So we basically have a key that's like frequency, I don't know, dash index, and then we can parse it out in order to know which one. Oh man, this is so bad. Yeah, exactly. Good call, rule. That's basically what I'm thinking. So it would be something like that. And then we just have to make sure to always grab the min, and then we can just sort it numerically. So yeah. Okay. So our heap will have an add method, and if we see that it already exists in the heap, then what? If you have more than one occurrence, it's disqualified anyway, so we just need to make sure that what? Yeah, you know, heaps, once again, terrible decision for this. So heaps, it's only convenient to remove the top node. So if we're updating an item that's somewhere in the middle, then that's going to be awkward. But I'm okay with living this. If you guys are okay with this, I'm okay with this. It's going to be battle around. Yeah, Q makes a lot more sense. Q makes a lot more sense, but it's not nearly as fun as a heap. Whoa, hey, somebody did something. Got a very loud buzz. Oh, here, we can, I forgot to hit play on the music. Oh, the music is just not playing for some reason. Oh, there we go. Alright, that may be super loud. I apologize. You'll have to let me know if it's too loud. Alright, most fun thing. Yep. No take backsies, we're doing a heap. So we'll add the item. So we need to have like some sort of basically a array or a list. We'll have a private list. A list called mutable list. But do we need it to be a list or an array? I'm fine with a list. We can't reassign it. There we go. Equals mutable list. I don't need to assign a size. I need to have a type. And why is this yelling at me? No value passed. Oh, come on. I just do list of strings. Side bets, yeah. Can I bet against myself? That would be great. So we just list.add push. Oh, I need a mutable list of. Man, there's gonna be people that join this list, this this stream late, and they're gonna be either confused or horrified. Could we? Yeah, I mean, I could definitely do an array. I could, I don't know how to can we malloc in Kotlin? Free heap. I don't know how you would do that in anything like Java. I know that there are some things like you can do with Java and pointers, but they kind of hide them from you. They definitely discourage them. Can you do a malloc? Well, let's see. New. I just want raw memory. So you cannot explicitly delete or free. Garbage collector. It looks like you can't just allocate memory like that. Yeah, so that's a bummer. And we could still get contiguous memory, but we'd have to do something like an array or something. So what are we adding here? Is it character? That's not enough info. We need to know a character, and we need to know its index. Int. That's a new signature for a heap. Never quite seen that one before. And what we'll do is we'll see if it's already in the heap. And if it is, this is a terrible idea. If it is in the heap, could we just remove it from that spot and then percolate down? I have no clue if that would work. That's definitely not what heaps are designed for, but it kind of sounds fun. Remove it and percolate down. And then we have the normal case, which is basically add it to the end. So we'll say else. Add it to the end of the array, or list in this case, and percolate up. All right, so that's not too bad. Percolate up is another function. We haven't decided on the format of this. What does it look like? We could do a new data class. The data class needs to know the character, the index, and the frequency. So why not have a third nested class? Data class called node. And in it we'll have, I'll call this value instead of car. It's like naming an integer int otherwise. So value, index and frequency. Oh, percolate. So I kind of don't want to look it up, but what the heck, we'll do it anyway. Heap percolate. When you talk about data structures like heaps, for some reason, I don't know why. I was looking for the Wikipedia article. There we go. For whatever reason, whoever invented the algorithm, the term I've always used for the operations that the heap has to do are called percolate up or percolate down. And yeah, I mean, like I think you pretty much call it like liquid or gas, like or kind of like either bubbles up or bubbles down based on the direction your item has to move. So in our case, I wanted to not cheat and read it, or yeah, I wanted to try and not read it and cheat. But basically, let's see if I can describe this. So what we're gonna do basically, if we have like a heap, which is a tree, but it's generally represented as some sort of list or array. So this is my, we'll call this a min heap, which means that normal use case, this item should always be the minimum. These are its two children. This one's children are this one and this one. So it's always sorted left to right. So another way to write this tree would have been like this. 1, 2, 3. 14, 12. And that's fine. I'm going to save myself some typing and just do this. And now whenever you add a new item to the heap, what you do is you always fill it in left to right. So in this case, it'll be a child of 3. So 20. And then you have to percolate up, which let me not do 3. Let me choose a 0 here. So this will be a new minimum. And so what we do is we percolate up is we look at its parent, say, hey, are you smaller than your parent? Yes, let's swap. Are you smaller than your parent? Yes, let's swap. And that's it. There's our heap. So it's great data structure for keeping track of either a minimum or a maximum, which is kind of what I was thinking with the frequency here. And the rest of the tree is almost sorted. You can see here my left child is actually bigger than my right child. So it's not a good data structure for maintaining order, which is what I'm needing here. So this is not a good solution for this problem, but it's fun, I hope. So that's what we're going to do, is basically write a percolate up that goes here, and then the same operation here. If we take this item out of the list, we take it out, and then we call a percolate. I forget now. We take the item out of the list, and then we call percolate down, which will then take the minimum of my left or right child. So in this case, it'll be the 1. We put it up, and then this one will take the minimum of its left or right child, which in this case is a 3. And our tree should still be balanced left to right. Well, let's do that again. In this case, we'll get the 2. So we remove the 1. The 2 should move up. And then we take the lesser of its 2 children, which is 12. And as we can see, the tree is still balanced left to right. Balance isn't the right word, but still filled in left to right. So it just, I don't know, it's a cool data structure. I try to use it whenever I can. So we need a percolate up function and a percolate down function, and I think that's it. Once we finish coding this, we'll have to insert some funky stuff that we'll have to debug through here in the first unique character to kind of handle the business use cases, but I don't think it'll be that bad. I don't think it will be. So here we just always add our item to the end of the string. So we're going to be taking a node and we add it to the end, and then we got to compare it with its parent. And equals, and that will be list.get, and the parent index is can be mathematically derived because we're always doing powers of 2. Oh yeah, we do such a terrible job of explaining diagrams and data structures. That's what we haven't done an episode on an algorithm or data structure in a while because it can be really hard to talk about abstractly without something to look at. Yeah, heaps are one of my favorites though. So the parent index equals, and I'm going to write down here because I think I kind of remember the children are always 2n plus 1. So for example, if we got a list of 0, 1, 2, my children are always going to be 2 times 0 plus 1 or plus 2. But to get to the parent, we got to take my index, which in this case is 1, and then we have to divide by 2. So it'll be n's index. I need to finish writing that up there. So it'll be my parent minus 2. And tell you what, since we're going to be writing some tests here, let's just do it outside of this. And we'll actually have these be properties of the node. So just because we're doing a bad algorithm doesn't mean we have to do nasty code. So let's write some short methods here that we can test. Right, Vlados? All right, so get parent will be a method that returns my index, divided by 2. I don't think that's enough. Wrong parentheses. So if I am my array here, I'll do a couple more, sure. So your parent right here, index 1, it's the reverse of these other functions, 2n plus 1 and 2n plus 2. So to do this kind of mathematically, we say parent equals parent's index times 2 for the 2 children, and then plus 1 or plus 2. I'm just going to ignore the plus 2 for now. So to solve for the parent now, what do we got to do? We got a minus 1, and then divided by 2. And then we have the issue where it's either minus 1 or minus 2, and we can just do that with a floor. So that should work. I just had a session of 2-3 hours because you don't have tests. Oh yeah, we're doing too much debugging. Import, sure. And it's not that, it's my index. Why is it yelling at me? I really don't want to cast everything to doubles. I really hate that. Oh, we can do it. Alright, and then get children will return a tuple, or as Kotlin likes to call it, a pair. At least I thought it was a pair. There we go. A pair of 2 times our index plus 1 and plus 2. Oh yeah, fun times, huh? So now we can write some tests, and I'll move these below afterwards. I don't know, we'll call this one get parent. We'll create a new node, and most of the data about the node doesn't really matter. I should name these index though. Parent index, get children index. Indices? Sure. Yeah. Do you have an infinite loop? Those are always fun. Lowercase. So if I have a 0, then I don't have a parent. So should I even bother testing that? Oh yeah. My frequency also doesn't matter. Oh, that's basically just data about me. So my node equals a node, and then we will assert equals, and if my index is 1, then my parent should be 0. Get parent index. And there we go. No. Is it because this is not an integer? Yep. Oh yeah. Circular reference. So my my right child of 0 should also be a 0. Oops, wrong one. So I should make this a var. And here I will also set your, that should be a 2. So both of these should have 0s. Oh cool, yeah, I like the music too. And it covers up any like weird breathing noises that I might make. Better for everybody. Oh, that was not related to today's code. Oh my gosh. Oh yeah, I didn't finish writing this code. Alright, let's just do that for now. Oh my gosh. I've made a mess. Let's see if I can pull it all back together in the end. Alright, cool. So the parent worked for 1 and 2. Let's try a few more. So if I say 3, my parent should be 1. Same with 4. And I guess I could just do this in line. Save some lines there. Get parent. 4 should also be a 1. 5 should be a 2. And so should 6. And if that works, then I think we can call this one good, this method. All right, hey, first time, all right, kind of first time. All right, and then we'll follow the same pattern basically for the children, just to make sure that's good so we don't spend hours debugging it later like I usually do. This will be 1, 1. Let's see. Do you guys ever have to like campaign for using tests? Like you have to sell other people? It can be very difficult. I definitely like the argument that the tests are actually to save time. And it's not really about correctness. But I don't know, I usually have a hard time selling it. Alright, so now if I say, we'll change this up a little bit. Delete those guys. Get children should be 2. Get children indices. So I'm just gonna be lazy and do something like this. So if I ask for the children of, we'll say index 0, I should get a 1 and a 2. And a 2. And this will be not 0, but first and second. That's some Kotlin goodness there. So we're saying 0's first children is 1 and its second child is 2. And then if we go and ask what 1's first child should be, it should be 3, and the other one should be 4. Yeah. Yeah, that's unfortunate, isn't it? We can't do the stuff that we're supposed to do because we don't have time, because we didn't do the stuff that we're supposed to do. What else? 2 should be 5 and 6. Yeah. All right, cool. So, hey, looks like we got the math right. That's good. I'll go ahead and get the stuff out of here. So it looks like we got the node right, which is like kind of the biggest part of the heap. So now we've got our actual heap. It's got a mutable list of, it needs to be a node now, not just a string. And so what we'll do is we'll create a node. We don't need to create a node yet, actually. We only want to create a node if we don't have it. And we can't use hashes or maps, so we've got to use probably an array. So let's see here. Call it maybe scene. Which is ridiculous. Equals an array of array of bits. So can we just do a binary number? We'll just set scene equal to a byte of 0. Byte is not enough. We need to capture 26. So a byte is big enough, right? Let me look up the Kotlin data types. Maybe there's like a short or something that's better. Short comes after byte, yeah. So byte is definitely big enough. I don't know, I'm thinking. Let's see, I was thinking of words. I don't have to deal with bytes very often. But it's words are different sizes on different system, right? Byte word sizes. So a word is 2 bytes, but I swear that I've seen 3 byte words before. Number of bits, blah, blah, blah. Oh my gosh. Typically have a word size of 10 or 12 digits. Whoa. Okay, some early computers had no fixed word length at all. That's interesting. Can the size for can sometimes differ from expected due to backwards compatibility, blah, blah, blah. So anyway, yeah. So byte is always 8, but a word depends. So good thing we looked that up. All right. So we're going to do all sorts of goofy stuff. This is going to be fun. So first we got to see if it already exists in the heap. So let's check our scene byte. If you know how it goes, RazTubes. So if scene, which is a byte, and now we have to convert, we have to normalize our character. How do we do that? Value to byte? Can I do that? Ugh. Value to byte. Hey, there we go. Minus a 2 byte. So that will give us a 0 base, but we actually need it to be 1 based here. So we'll call this reference. And that's a constant. So let's do that. Yeah, I'm making a proper mess here. member declaration. Oh, I can't set it to a const because that. Yeah, so I'll set this to our reference. All right, so scene and value to byte minus reference. So value to byte minus reference will normalize our character to a digit between 1 and 27. And if our scene do I want to do this? I don't know that I want to do this as a byte. Just really have to get this to be that. This would be like 2 up to the. Yeah, no, let's not do that. Sorry, that was too crazy. That's just gonna take too long. So let's just make a scene an array of integer of booleans. Yeah, it would. That's why I was hoping to minus like a as the reference so that it would normalize it to basically a number between 1 and 27. But yeah. I don't actually care which one it is. I think because of the normalization, I think it would have worked. But now we'll never know because I wussed out. 26. Oh, I guess I still need to know that, don't I? I guess we'll find out. I still need that reference. Why is this yelling at me? No value passed for parameter in it. I gave it it needs an initial values. That's nice. And that's because booleans are primitive, I believe. They are not nullable. So here I have to give it some sort of value to start. Why does it not like it? What? Why does that want an integer? Oh, it's a method. Okay, sorry. Sorry about that. It needs a function to initialize the value. Like this. There we go. And this is another weird Kotlin thing where this is technically an argument. So that's valid syntax, but if you click on it, they actually, the style guide recommends that you move your lambdas to the outside of the argument by default, if they're the last argument. It's kind of weird. All right, so we've got an array of falses, and we've got a reference which can now be 0 based. So here we can do our value.byte minus reference, and this should get us a number between 1 and 26 that we can check to see if we've seen this number before. All right, and so seen at index. If we've seen the number before, then what? Remove it and percolate down. Else, add it to the end of the array and percolate up. Do we need to write a test for this? Nah. Ugh, why is this? Make it private. Okay, I'm fine with that, JetBrains. Thank you. What is this problem? New shadowed index. Because our node has an index? Is that what it's seeing there? Oh, that's kind of weird. Shouldn't be. Oh, it's shadowing this index, the one I'm taking in. Okay. We call this one letter index. And this index is going to be word index. Yep, good call, Rule. Thank you. All right. Okay, that's fine. And this will be done. Okay, so this one's easy. List.add, and we're going to add our new node. So node equals node, and the value is value. Our index is the word index, and our frequency is 1 because I've never seen it before. And then we're going to call percolate up on our node. That's it. Now this one's a little bit trickier. So it is in the array. So what? How do we find it? Remove it. Makes me question this array of booleans. Maybe it should be an array of nodes, nullable nodes. Nullable nodes, and we default it to null. So here, it's not going to be seen at, it'll be seen at this not equal to null. Okay. So if we have an item at this index, then what? Well, we have to update this to let it know that we've seen it. So that's fine. To do, then our node equals this. Node.frequency needs to go up 1. Which means I need to make this a var, not a val. So by default, it's immutable. So for the scene array, I'm doing 1 for each letter. Let me double check that. Why do I still have this open? All right. Only lowercase letters, so that's why I'm only doing 26. It's English language 26. Is that right? It's been a while since I thought about it. Yeah, so oh yeah, that's a good point. So roll I don't know if you're here when we said this, but hey, what's up, Alan? You're gonna love this, Alan. So we said this problem was too easy, so rather than just looping through the problem to find the first, looping through the array to find the first unique character in a set by like keeping a quantity in a hash map or something, we said we're gonna try and solve it with a heap. For no good reason. It was because RazTubes won the vote. So we're doing a frequency heap. And by the way, heap makes like 0 sense for doing this. But here I am percolating up and percolating down. And we're doing it in Kotlin. Yeah, so having some fun today. Okay, and our node can be null, but we know it's not. So there we go. Thanks, Kotlin. So we update the frequency. Now we have to call percolate down or something. We need to call something. I don't know. This is goofy. Something. We said remove it and percolate down. Do we need to remove it? We only need to remove it if its frequency is 2 now. Because we only care about the ones where it's 1. So if the frequency now equals 2, meaning it used to be a 1, we need to remove it and percolate down. This is the world's worst heap. I don't even like calling it a heap. It's awesome. Percolate down. And do we actually need to remove it, or can we just percolate down where it is? Oh my gosh. Yeah, this whole calling this a heap is not accurate. Oh my gosh. The deal is that if we remove it where it stands, I don't know what needs to happen. Like, I don't know how, if you can use a heap with items that can change their numeric value after you already put them in the heap. This whole thing might be totally flawed. I don't know. I need a lifeline. Alan, help me out. Instead of removing, replace them by delete character. Okay. And then we could just search for the first non-deleted character? Is that what you're thinking? Huh. I like how this just keeps growing and growing. Like, the requirements make no sense. I keep adding more and more code and getting less and less done. This is too much like my real life. Scope creep. Yeah, so what if we just said node dot letter, node dot value equals a character that we don't care about, like blank, which means you need to make this a var. Yeah, you're right. If we orphan the child, then it's no longer a heap. Yeah, it's like if we remove this, it would no longer be a heap, and we would not satisfy the requirements. Oh, you can't have an empty character literal. All right, how about a question mark? And then we don't need to percolate. Is that right? Yeah, I don't think we need to percolate. So this is a heap. This is the world's most efficient heap because you never need to percolate down. All right. It means we're going to have extra work to do later, but that's okay. Kick the can. All right. So percolate up. Now this one we still need to do. We create a new node here. Oh man, we're just having fun. Anyone looking at the solution knows I should be embarrassed to be a professional programmer. And we're just having a good time. So we'll add our n. Yeah, this should be private. We don't even need this somehow. Hey, we could watch a cool visualization on heaps. Visualization. I think we talked about this one on the show. So for like it added a bunch of numbers, we can see how it constructs it. So I added a big number there. So if I add a 1, it should end up swapping to the top. Yep. If we add a 0, it should end up getting swapped to the top. I wish I could just do randoms. Let's see, 14, 123. So I'm just gonna do a bunch and then we'll do like a negative number or something. You see how it's always filling in left to right no matter what I do? Alright, so now I'll do a negative 1. It should put it as this child, and then it should bubble up to here, and finally bubble up to the very top. Oh, this visualization doesn't take negative numbers. So I'm going to do a 0 and it'll just stop here. That's a bummer. Oh, no, tell you what, there we go. I removed the 0. So yeah, now I can do a 0 and we can see it happen. So I'll add a 0. It'll end up going to the left child. Vlad, what time do you... Oh yeah, you're in a much different time zone. Are you up early or up late? Add a 0, percolate, percolate, percolate. The idea is that minimum, in this case, is always going to be on top. So you can always remove the smallest, and it's going to figure out which one is the minimum here. And then the way it does it is kind of funky. It doesn't just look at the next child. It actually puts the item down at the bottom and then percolates up. And that's how it maintains the left to right filling in. So we add this item at the end. Which I already added. Specifying a fixed value wouldn't work. Same time zone, heck yeah. What's the name of that time zone? No, I guess I don't want you guys to give away your PII. I was talking to someone from Brazil last night, and it's so weird to me that the seasons are reversed, like northern hemisphere, southern hemisphere. Hey, nice roll. Like a guy from the chat from Slack is in the Netherlands. Are you guys still locked down? Heck yeah, East Coast, West Coast. I know guy lives near a border, so like he had family and friends on the other side of the border, and he wasn't able to cross because of the quarantine. It's just crazy to me that it's just a few minutes away, but can't go there. So we've got our item here at the end, and so we need to do is get the parent index, and then our parent equals the list at the parent index. But we only need to do that if our node is not 0. That's a special case where if node equals 0, then we could just return, we're done. Otherwise, find out the parent index. And if the parent value is greater than us, then node.value, then we need to swap them. Hey, yeah, there you go. That's so crazy to me. I don't live near any borders like that. Whoa. So you guys, are you familiar with Cinco de Mayo? Cinco de Mayo. It's a Mexican holiday. Yeah, this is a good question. I don't really know. I just think restaurants tend to have specials and stuff. That's all I really know about it. But yeah, we tend to talk about it as if it's Mexican Independence Day. But I don't really know a whole lot about it other than, you know, it's a reason to celebrate. And hopefully it's a good one. Now I'm kind of scared. I don't know. Anytime there's a battle, there are winners and losers. Let's see. So I realized another problem here. Anytime I swap indexes, I have to update our our scene array. So awesome. Okay. So if the parent value, and actually we don't care, it's not the value that we really care about, it's the frequency. If the parent frequency is greater than our frequency, then what? Then we set a val temp index equals our parent index. And then we set our parent.index equals to n.index. And n.index equals our temp index, which means that also needs to be a var. So this is definite code smell. I like that about Kotlin is we're changing another object's members. So we're reaching into something else to change that. So that's some stank right there. That's unfortunate, but I'm not going to change it. So we did this. That's good. But now we also have to update the scene array. But, you know, I take it back because in the scene array, both are already going to be in there. They're just pointing to the wrong nodes. Yeah, so we do have to update that. So scene at n.index now equals n, and scene at the parent index equals parent. Does anyone remember the problem that we're still solving? I should say, still remember the problem that we're still solving. So I kind of don't anymore. Lost in the haze. Lost in the Kotlin. I think that's good. I think we do have to do more work here. Yeah, awesome. Me too. Me too. I think that we have to percolate down, honestly. I don't think it's enough to change the value because potentially there could be children of mine that have a lower frequency. So while it's okay to change the value, we also have to call percolate down, which I deleted. So I think we could skip that actually. So let's do that. All right, now we need a new function called percolate down. Hey, I never recalled this recursively. So if we do a swap, we also have to call percolate up on our parent. Or not a parent, our current. So this is funky. We call it with the same input, but now things about this have changed. That's funny. And if it doesn't change, then we're done. Is it letting me know that I've got a recursive definition? That's funny. Is that actually blocking me? Because I am checking item about the info. Come on, don't do me like this. Okay, that's gonna do me like this. Let's change this to be the index. It's an integer now. And now we can do val n equals our scene at index. So this is literally just to get us around the compiler error that's trying to save us from an infinite loop. We don't need that. There we go. All right, cool. So we've gotten around the check for infinite loop without solving the problem. Awesome. Take that, Kotlin. Take that, safety. I tell you, I have like a quarter of a glass of wine, and I get wild. All right, percolate down now. And we'll take an int again. And what we'll do is we will get our node at scene.index. We can rely on always being there, not being null. Now we have to get our children. Get children indices. I think we can destructure like this, but I'm not totally sure. Oh no, it's first and second. Did I do that right? I did do that right. Awesome. So I destructured the return. Got my children. I could even call them left and right, I believe. Left and right. And then what? If the left frequency, if seen at left dot frequency, seen at left index. There we go. Seen at left index. Dot frequency. I also have to check the check bounds. If your frequency is less than mine, one of my children has lower frequency than me. Then we need to swap. Why does it not like that? Because it's possibly nullable. So we'll do val left equals this. So if left and there's me doing some JavaScript there. If the left is not equal to null and the scene frequency is less than the node frequency. I don't need to call that. I can just call that left now. And we need to swap. And the way we swap is exactly like above. So let's make this a new function. Keeps getting bigger and bigger, called swap. And we'll take 2 integers. Why did you guys let me do this? Oh my gosh. So temp equals A. Parent equals A, sure. And N equals B, and then we'll rename these here in a second. What is going on here? Function declaration must have a name. Oh, I didn't call it a function. There we go. So parent equals scene, N equals scene at B, and then we basically swap these things around. Okay, and now maybe we'll call this A index and B index, because that's what time of night it is. And then here we can just call these A and B. Whoa. Okay. So then up here we can just say swap. Parent dot index and end dot index. All right, and then we can do the same thing down here. I'm seeing the light at the end of the tunnel. I think we got this. So we swap left. And actually, we need to always take whichever one is less. So we have a little bit more work to do here. So we'll get right as well. And we'll have a swap. So if left is not equal to null, null, and right is equal to null, then we know that swap equals left. else, do one more up here. If left equals null and right equals null, and let's just get out of here. Else, if left equals null and right, left is not equal to null and right equals null, then swap equals left. Otherwise, we have to compare else if, say or, left dot frequency is less than n dot frequency, no, right dot frequency. Then we take the left. In all of the cases, we take right. Okay. So then we just swap our swap index with our n index. Donezo. All right, make sure Kotlin knows. Oh, that's cool. I didn't realize you could do that. So I made it a val, but then I conditionally set it, and it's smart enough to recognize. Lift assignment out of if. Oh, whoa, look at that. Val equals if. That's pretty weird. Wow, okay. Make sure I got some parentheses here, but that's a pretty cool little trick there. I don't need that anymore. There we go, okay. And then here, I just always swap. But only if the swap index, so I don't always do it. If the swap frequency, if you fall asleep, I'd like to remind you that this is not my fault. This is all your fault, RazTubes. If the swap frequency is less than n's frequency, then we swap. And if and only if we swap, we need to percolate down with our new index, which will be n.index. Percolate. Percolate down. And if we don't swap, then we're just done. All right, I think that's it. We check the bounds, right? Oh, look at this, left index, left index. If left, I don't know, maybe I can just do that. And I'll return a null if it doesn't have it. I kind of doubt it. We'll try it. Alright, so for the actual problem we're solving, I should probably write some tests. But I kind of don't want to. Because tests only make things faster and better. And ain't nobody got time for that. So what we do is we create our frequency heap. Loosely named. Let's see, val heap equals frequency heap. No arguments. And we're going to loop through. Oh, I forgot one thing. If the frequencies are equal, then I also need to check, oh my gosh, to see which one has the lesser index. Oh my gosh. What's the easiest way to do that? I need an else. I might need a couple else's. if the swap dot frequency equals n dot frequency, that's actually, it's going to change the swap. All right, RazTubes. What do you say we just solve this problem? Like the normal human being way. Because I just realized I need to go add like 20 more lines up throughout here. Will you release me from my vow? And while I'm waiting for you to answer, I'm going to solve this real quick. S dot for each. All right, thank you. This is it was fun, but it was horrible also. That is not a good way of solving this problem. Have I ever mentioned that I love quitting things? Anytime plans are canceled or things are quit, it just feels great. What am I doing? S dot for each. Is that the best way to do this? You know, I didn't spend any time thinking about how to actually solve it, but I mean, is there an ordered map? Ordered hash? Come on, Kotlin. There's got to be an ordered hash. To sorted map. Converts a map to a sorted map. Turns equality and order of the keys. What? According to their natural sorted order. So I can take any comparable of key and value and map out to sorted map. So if I had a 3, 2, 1, then I should get sorted values of 2, 3, 1. What? Oh, that's alphabetical sorting. I need ordered, not sorted. I need an ordered map. What about a linked map of? Returns a new linked hash map with a specific contents given as pair list pairs where the first component is the key and the second is the value. If multiple have the same key, the resulting map will contain the value from the last of those pairs. So if we created a map here of like 1 to x, 2 to y, -1 to zz, then it's sorted based on the value. So this is basically what I want. Two to y, -1 to z. Maybe this is not what I want, is it? What? In the order they were specified. Let's just try it. How would this work? Linked hash map returns a linked hash with specifically because a list of pairs where the first component is the key and the second is the value. If they have the same key, the resulting map will contain the value from the last of those pairs. Oh yeah, I don't want that. So now that we've tried to do it in a possible way, I want to find the easiest way. There's got to be an ordered collection. I mean, come on. C# has it. C# ordered. Is it called ordered dictionary? Represents a collection of key value pairs that are accessible by the key or the index. Yeah, the indexes are sorted. You just need the first one that satisfies the condition, being frequency count equals 1. You don't need to sort. The indexes are sorted. Oh, maybe I didn't read this problem very well. Maybe I was telling the wrong problem the whole time. First, unique character in a string. So, I mean, I could just loop over the string twice. That would have an end runtime. It's not elegant. I need a first occurrence. Yep. So can I do like... Let me just delete all this monster. Ah, I feel free. Iterate through the characters of the string. Search the entire string for the character. Oh yeah, if count equals 1, return that index. Yeah, I like that. I was thinking about doing basically like s.count or grouping by, I think it was grouping by. Found this function the other day. We're going to group by it. And then count each count. Alright, so check this out. So this will get our groupings, or we'll call them frequencies. And then, so this is not efficient, but it's still got an end runtime. And you don't need to loop the character values on the second pass. Yep. Wait, from A to Z. We return the first item based on the string. Like in this case, we returned 0, 1, 2, the V, so it's not the first alphabetically, it just happens to be the first one that isn't duplicated. Oh, it's both. Dang it. Yeah, well, this one, the D is first alphabetically, but we still return 0 because it's the first one occurring in the string. So I think basically we can do is s.for each, and using a little trick we learned yesterday as well, what we can do is basically if frequencies at it equals 1, then we can return. And the item that we're returning is frequencies at it. Otherwise, -1. I think that's it. Let's see here. Oh, it wants the integer. All right. Uh-oh, why is it yelling at me? Change the return type of function to car. I don't want car. Oh, I need the index of S. So let's see if there's any way for me to get that. I want like for each index. For each indexed. All right. And it's going to give me the int and then the car. All right. And that'll be I and then C. So if frequencies at C equals 1, return I. What? Why is it yelling at me? Uh-oh, hold on. All right, sorry about that. I'm on the hook for Bacon Tacos in a few minutes, so good thing we gave up on that current solution. Thank you for freeing me. For each index, and what was the problem here? I believed I was an integer. So what's the problem here? I could do an old school for loop, I guess, but I thought I had this right. We pass an action that takes an index named I and a character, and we return a unit. And then that's all it does. It's supposed to give us our index. And then it calls an action which returns a unit, but I think the unit can be anything. So is that the problem? That I'm not returning anything else? Nope. I know it's unused. What am I doing wrong here? I'm feeling I'm going crazy. Your character. That's what all these squiggles about. Parameters type int card. Destructuring declaration initializer of type int must have component one function. Is it because I did parentheses? I didn't mean to destructure. I just wanted to take these guys as they were. That was it. All right, so a little Kotlin snafu there. But like we learned yesterday, a return in a lambda is actually going to return the whole function, unless I actually told it like at for each indexed, which is weird, but I like it. Dude, Kotlin is definitely used for Android, yes, but that's not what I use it for at all. I love it for just general JVM stuff. So if there are any libraries in Java that you need to interact with, then I by far recommend Kotlin over Java. And I don't know much about Scala, but from what I've seen, you know, Kotlin is, I think, a pretty far ahead of everybody. And there are a ton of libraries that are available in Java that aren't available in C#. And likewise, there's tons of stuff available in C# that isn't available in Kotlin. But so many of like the like cloud native computing foundation, like these guys, like they're so heavily like Java first, if not Go first. What are some of the projects? Graduated incubated. Yeah, so like all these projects are like super Java friendly, super duper Java friendly, and Apache, don't even get me started. Apache projects, like just heavy emphasis on Java. So if you're doing stuff with like Elasticsearch or Lucene or Kafka or any of that stuff, even AWS is a pretty strong bent towards Java. So if you want to play around with any of this stuff, like it's probably going to be Java first. And you don't have to do any of the nasty Java stuff with Kotlin. It's just a nice language, and it feels like C# to me. It feels like JavaScript to me. It's like C# and Java, or sorry, not Java. It's like C# and JavaScript had a baby, a beautiful love child named Kotlin. And yeah, there's a couple little quirks. It's definitely very opinionated about things like mutability, but the IDE makes it really great. And honestly, the hardest thing for me was just the IDE in general. So getting used to like the new shortcuts and stuff coming from like Visual Studio and Visual Studio Code background. But you know, I still stumble for sure. But man, what a way to fall! And so many built-in functions, just awesome. Yeah, the details aren't too terrible. Let's see if this just works. First time, no tests. All right, awesome. Hey, not the best answer. Let's see if anyone else did Heap. Let's check out this one. Int array. Okay. Okay, yeah. So they did a 2-pass. That's fine. So it's really the same thing, just they did a little bit better about the details. So that's cool. But yeah, a little disappointed to see that the top solution didn't use a heap. I think we could have beaten this one. We could have had a winner. Could have had a 100%er here if we just pushed on through with that heap. Nah. I think that heap probably, if we had finished it, first of all, it probably would have been another hour. And it probably would have exceeded the timeout. No, I don't know if that's true. I don't think that's true. I think it would have been at the tail end for sure. but I think I would have made it. I believe in it. So anyway, I'm gonna go make tacos and finish my drink. So hey, happy Cinco de Mayo. And for you folks where it's like 2 in the morning, I hope you have a great day and get some sleep. All right, adios.